Chapter 12.3, Day 1, the tangent line problem. We're going to look at understanding the tangent line problem, use a tangent line to approximate the slope of a graph at a point, and use a limit definition of slope to find exact slopes of graphs. So a slope of a graph. A tangent line approximates the slope of the graph at a point. So the problem of finding the slope of a graph at a point is the same as finding the slope of the tangent line at the point. So example 1, we're just going to practice visually approximating the slope of a graph. Using the figure on the right, approximate the slope of the graph of x squared at the point 1, 1. So they have it already done for us, and we notice 1, 1 is here, and they drew a line tangent to that point. And so they already did the work for us, so we can say it's approximately right 1 up 2. And so remember, slope is the change in y over the change in x. So therefore the y's change a positive 2 and a 1. So therefore the slope is 2 at the point 1, 1. Now try that at the point 2, 4. So we're using the same graph, so write 2 up 4, and then try to draw a line through that and find out what is the approximate slope at that point. So if you tried it out, so here is my line here, if you can kind of see it, it's this line here. And so that is approximately 4, 1, okay, 4, 1. Now let's do some more approximations of slopes. The figure on the right graphically depicts the monthly normal temperatures in degrees Fahrenheit for Dallas, Texas. Approximate the slope of this graph at the point shown and give a physical interpretation of the result. So again, they did a lot of the work for us here on the graph. So here is the graph. The point is at 1067. That's the point they were looking at. So what is the slope of the line that goes through that point? And so here it is 10, 1. Now you have to be careful, number one, that it is a scaled graph. So just be careful with that. And then so they found that it's approximately 10, 1. Now it's negative 10, 1. So again, slope. So it's up 10, which is positive, and then left 1, which is a negative 1. So slope is negative 10. Now what does that tell us? Well, just to kind of give it to you right here, the slope of negative 10 degrees means that the normal temperature in November, so this is November if you look at the graph, it's November. And so the normal temperature in November is about 10 degrees lower than the normal temperature in October, right? So here is October, this is November, so it's 10 degrees lower. So try doing the same thing here. Approximate the slope of the graph at the point 466 and give a physical interpretation of the result. So we're looking at positive 4, so that's April, and at 66 degrees, what is that slope, approximately? So in this one, you would find that the slope is positive 10 degrees. The slope of 10 degrees means that the normal temperature in May, so the month after, is about 10 degrees higher than the normal temperature in April. So looking at this here, this is 4 right here, and then May is here, and so that's about 10 degrees difference. So slope of the limit process. In the first examples 1 and 2, we approximated the slope of a graph at a point by creating a graph and then eyeballing the tangent line at the point of tangency. Now there is a more precise method of approximating the tangent lines using a secant line for the point of tangency, and a second point on the graph is shown below. And then so just to kind of go through that, what this looks like, slope of a secant line. So slope of the secant equals the change in y over change in x. And we're looking at this equation here. So that should look very similar to you, hopefully, like the difference quotient. So notice that the right side of this equation is a difference quotient. The denominator h is the change in x, and the numerator is a change in y. Using this method, you obtain more and more accurate approximations of the slope of the tangent line by choosing points closer and closer to the point of tangency. So look at these graphs below. You can kind of see that. So they pick 2 points here, secant line, then closer and closer, and then it gets so close that it is now the tangent line. So that is what it's talking about here, the limit process. So using the limit process, you can find the exact slope of the tangent line of x of f of x. So that's what we're going to practice on next. So definition of the slope of a graph. The slope m of the graph of f at the point x f of x is equal to the slope of its tangent line at x f of x and is given by this equation. So we're going to use this. M equals the limit of the secant line h as h approaches 0, and that's the limit as h approaches 0 of f of x plus h minus f of x over h. As suggested in section 12.2, the difference quotient is used frequently in calculus. Using the difference quotient to find the slope of a tangent line to a graph is a major concept of calculus. So let's apply it here. Finding the slope of a graph. Use the limit process to find the slope of the graph of f of x equals x squared at the point -2, 4. So we're using the difference quotient, so that's f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. So we're going to plug that in to our equation x squared. So the first one, so let's do this in pink so you can kind of see it. So this one is just x squared, so that should be pretty fast. So the limit as h approaches 0, and we're going to plug in x plus h where we see the x. So this is going to be x plus h squared. And then minus f of x is just x squared, all over h. Now, what's nice about this problem is that they give us a specific point, -2, 4. So this is our x value, and this is, of course, our y. Now, the thing with the x is we can plug it in directly into this equation. So let's do that now. So the limit as h approaches 0 of -2 plus h squared minus a -2 squared. Okay, so now I could replace the 2 value in there, and then now we can evaluate this limit. So the limit as h approaches 0, this is 4 minus 4h plus h squared, and then -2 squared will be a positive 4, right? This will be positive 4, which will end up being a -4 because the sign is negative here, all over h. So this is the limit as h approaches 0, and then 4 minus 4, that cancels. So we're left with h squared minus 4h all over h. Then simplify a little bit more. Limit as h approaches 0 of h times h minus 4 over h. The h cancels. We now are looking at the limit as h approaches 0 of h minus 4, or 0 minus 4, which is -4. So that is our slope of the secant line at that specific point of -2, 4. So try that example here. Use a limit process to find the slope of the graph of g of x equals x squared minus 2x at the point 3. And that last number is 3. Now, it doesn't really matter because we don't need that y value, but just so you have it, that is at the point 3, 3. And then be careful, as a side note, there is an x squared here, and there's also an x here. So make sure you plug it all in the correct places. All right, so if you tried this out, so hopefully you plugged it in correctly first of all, so the f of x plus h, and then I did immediately plug in the 3, so knowing that x is 3, I just plugged it in all at one point. So 3 plus h squared minus 2, because there's a 2 here, times 3 plus h, and then minus, this is the, again, this here, x squared minus 2x, so x is 3, 3 squared minus 2 times 3. All over h. So hopefully, number 1, you got it plugged in correctly. The rest is just the algebra involved in solving for it. So you would find that the slope here is a +4.